Hello dear students, good evening to each and everyone. All of you, welcome back to the Get Wallah English channel. We are studying signals and system in comprehensive manner, and total we completed 25 lectures, and this is lecture number 26. We are studying classification of signals, and in this topic this is part 5. Last class we have seen periodic signal. In that we have seen continuous time, periodicity for the how to check the periodicity of the continuous time signal. Today we will see discrete time signal. So first of all, tell me, am I audible properly? Audio and video both are clear to you people? So let us continue further. Today we will finish all these topics. How to check periodicity for the discrete time signal, then we will see bounded and unbounded signals, analog and digital signals, and random and deterministic signals. Periodic and aperiodic signal, as of now we are studying. So let us consider x of n is a discrete time signal. So definition wise it is same as that of continuous time signal. Discrete time signal x of n is said to be periodic if x of n equal to x of n plus or minus kn. X of n is equal to x of n plus or minus k into n, where again k is integer value. Here see, as this is the discrete time signal, small n, k and capital N all are integer values, correct? Where capital K is integer value, and capital N is what? Fundamental time period, number of samples, fundamental time period. Fundamental time period. Okay. So in this also we will see the periodic signal, periodicity for the non-sinusoidal periodic signal and periodic signal. So see, all the continuous time signals, all the continuous time sinusoidal signals are always periodic, but not all discrete time sinusoidal signal. Discrete time sinusoidal signal may or may not be periodic. This is very much important conclusion. Let's see. So first of all, we will see the periodicity of how to find the fundamental time period for the non-sinusoidal periodic signal. Let's consider this example. Now, show this. is -5. Fourteen and so on. Okay. This is origin. Is present at origin. This is what non-sinusoidal periodic just mark amplitude 1 minus 1. Now here certain samples will make one group and that pattern will be repeated. Okay, suppose here we can see this 1 2 3 4 5 samples. These 5 samples will make one pattern in, okay, and same pattern is repeating, guys, with same number of samples. 1 2 1 3, here amplitude is 0, here -2 and again 0. This also you have to consider. Now another 5 samples, 1 3 0 -2 0, guys, 1 3, here 0 -2 and 0, same pattern. These 5 samples are making same pattern, same as this. Here also, here also. Next also you can see. So here the fundamental time period, number of samples in this group is known as what? Fundamental time period. So here fundamental time period is n equal to fundamental time period. N is equal to what? 5. You can cross verify also. X of n plus or minus k into n. Okay, where x of n plus, let us consider k equal to 1, and here 5. Okay, 1 2 3 4 1 2 3 4 and 5 samples, 10 plus 5. So here suppose x of 0, n equal to 0. If you put n equal to 0 here, n equal to 0, what is the value of x of n at n equal to 0? Is 1. Okay, now x of n plus 5. Okay, x of n plus 5. So n equal to 0 here, n equal to 0, so x of 0 plus 5, of 0 plus 5, that is x of 5. What is the value of x of 5? You can see here, x of 5 also 1. So x of 0, this is x of n, guys. What? X of n equal to 0 at n equal to 0. So you can see here x of n equal to 0 and x of n plus 5 at n equal to 0, both are same. That's why this is the periodic signal. Here we can say x of n plus 5, which is equal to x of n. So yes, here this is periodic signal with the fundamental time period capital N equal to 5. So this is non-sinusoidal periodic signal with the discrete time. Okay, in this way we can calculate the fundamental time period. Fine. Okay, now let us continue. Now how to find the fundamental time period of discrete time sinusoidal signal? Again I am saying all the continuous time sinusoidal signals are always periodic, but not all discrete time sinusoidal signals are always periodic. Discrete time sinusoidal signal may or may not be periodic. It will be periodic under the certain condition. Exactly I am going to x of t is equal to a sine omega t plus theta, So this is always periodic. Continuous time sinusoidal signal is always periodic. Okay, this is always periodic. Always periodic. And here omega is equal to fundamental frequency, nothing but pi by capital T by f, and capital T is fundamental time period. Fundamental time period. Okay. Now, how to convert this continuous time signal into the discrete time signal? Tell me the process. Process of converting continuous time signal into the discrete time signal is known as what? Is known as the sampling process. See, you have to replace T with n into Ts. But n is a integer values. Okay, and Ts is sampling period, guys. Sampling period. Time period or duration between two samples, and it is inverse of sampling frequency n into by fs. Fs is sampling frequency and ts is sampling period. Already you know this. Okay, so it will be converted into discrete time signal x of n. Once you replace t with nts, once you replace t with nts, it will be converted into the discrete time. Now here there is no guarantee that after conversion it will be periodic or aperiodic. Okay, there is no guarantee of periodicity. It may be aperiodic, guys, or it may or may not be periodic. Out of camera, let me check once. Camera only, correct only, is right only. Okay, please check once. Omega, replace t with nts, so n into ts, n into ts plus theta. Okay, n into ts plus theta, and ts is equal to omega equal to what? 2 pi a sine phi f n fs, correct? Ts equal to 1 by fs, omega equal to 2 pi f plus theta. So x of n is a, x of n is a sine phi f upon fs. What is f, guys? It is the frequency of continuous time sinusoidal signal. F is frequency of continuous time sinusoidal signal plus theta. Okay, let us consider this is the frequency for the discrete time sinusoidal signal. Omega is equal to phi f upon fs. Then this x of n will be a sine omega n plus theta, correct? Let us consider 2 pi f by fs equal to omega of frequency, then it is a sine omega n plus theta, guys. Okay, now this is the discrete time sinusoidal signal and this is the continuous time sinusoidal signal. Okay, this is the discrete time sinusoidal signal, this is the continuous time sinusoidal signal. Now this discrete time sinusoidal signal may or may not be periodic. It is not always periodic. This is very much important conclusion. Why? That also I will tell you. It may or may not be periodic signal. Correct? It may or may not be periodic signal. Fine. How and why, that also I will tell you. In which condition, under what condition it will be periodic, that also I will tell you. Let us discuss that condition. So let us consider discrete time sinusoidal function. It can be cos, it can be sine. For simplicity, I am taking cos. So cos or sine also you can take. No, sine omega n plus theta. Now it will be periodic only if x of small n plus capital N equal to x of n. So let us find x of n plus capital N, and if this is equal to x of n, then we can say this is periodic with the fundamental time period capital N. Replace n plus capital N plus theta, okay, equal to a sin omega n plus theta plus omega into capital N. Okay, now tell me, it will be x of n only if this omega n equal to what? Omega into capital N. Can we write like this? If this omega is multiple integer of 2 pi, if omega into capital N is multiple integer of 2 pi, then and then multiple integer of 2 pi, correct? Like k equal to 1, then it is 2 pi, 2 pi plus this angle equal to sin omega n plus n. If k equal to 2, then 4 pi. So if multiple integer of 2 pi, correct? If it is multiple integer of 2 pi, then we can say then x of n plus capital N is equal to k sin omega n plus theta plus pi k, where k is integer value, guys. K is integer value, remember this thing here. K is integer only, correct? K is integer only. So x of n plus capital N is equal to k sin omega n plus here. Now here this is equal to, in this condition only, guys, see, if omega n equal to 2 pi into k, then and then it is x of n, and we can say it is periodic, guys, correct? So here we can say if omega n, that is omega by 2 pi is equal to, I am writing k by n, okay, then x of n is periodic. Okay. Here now very much important conclusion, guys. If this signal satisfies this condition, then and then we can say it is periodic. Now very much important conclusion, see here. Then writing omega by 2 pi, which is nothing but k upon capital N. Okay. Now see, here k is integer only, guys. It is integer only. It is integer. It is integer only, correct? And capital N is a fundamental time period. So capital N is a fundamental time period. So fundamental time period should be integer in discrete time. Here this capital N, it should be integer only. Okay, it should be integer only. Clear? See, k is already integer value, and capital N is the fundamental time period for the discrete time. So that's why capital N should be integer only. So numerator is integer and denominator should be integer. So denominator should be integer only if k by n is a rational number. Can we say like this? If this ratio is a rational number, this is possible only when this ratio omega by 2 pi, you can say this is possible only. Numerator is integer and denominator will be integer only if omega by 2 pi ratio is integer rational number only, because ratio of two integer value always rational number. So this is possible only when only when this ratio omega upon 2 pi is rational number, and if it is rational number and omega by 2 pi is rational number, then we can say the given x of n is a periodic signal and capital N is a fundamental time period. This is possible only when omega by 2 pi is a rational number, correct? Then x of n is said to be periodic. Okay, and x of n is said to be periodic, correct? So in this condition only, if omega by 2 pi ratio is rational number, then and then x of n will be periodic and capital N is a fundamental time period, correct? Is this clear? Nikhil, tell me. This is very much important conclusion. So if omega by 2 pi, how to find omega? From the question. Definitely from the question we can find the value of omega. And next you have to check omega by 2 pi ratio. If omega by 2 pi ratio is rational number, then and then we can say x of n is a fundamental time period with capital N is a fundamental time period. Sorry, x of n is said to be periodic with fundamental time period capital N. Fine. Now let us take one question. Find the fundamental time period of the signal x of n, not x of t, the discrete time signal is x of n. X of n is equal to 3 cos pi n by 7. So compare with the standard format, compare with x of n is equal to a cos omega n. So from here omega is equal to 2 pi by 7, correct? 2 pi by 7. Now find omega by 2 pi. If you find omega by 2 pi, then it will be 1 by 7. Now check 1 by 7 is a rational number or irrational number. So 1 by 7 is rational number, and if it is rational number, this indicates x of n is periodic signal. X of n is periodic signal, and it is equal to k by n. Numerator minimum integer, denominator minimum integer. So capital N is equal to 7 is a fundamental time period. Fundamental time period. Correct? It is the fundamental time period. Capital N equal to 7 is a fundamental time period. Now let us check whether this is right or wrong answer. Simply x of n plus 7 3 cos pi by 7 n plus 7 is equal to 3 cos pi n by 7 plus this pi, correct? 2 pi. Now cos 2 pi plus theta is equal to cos theta equal to cos, correct? And which is equal to x of n. So here we got x of n plus 7 is equal to x of n plus 7 is equal to x of n. So hence x of n is a periodic with the fundamental time period. Capital N is equal to 7. Fine. So capital N is a 7. Capital N equal to 7 is a fundamental time period. Now let us see the next question. Again, this is not x of t, this x of n. X of n is equal to cos n by 5. So check whether this is periodic or aperiodic. Periodic or aperiodic. So x of, compare with the standard format, x of n is equal to cos omega n. Omega n is equal to 1 by 5. Now omega by 5, 1 by 5, 1 upon is 1 upon 10 pi. 1 by 10 pi. Now tell me, 1 by 10 pi is a periodic or aperiodic? Yes, still very good. You got the correct answer. It is aperiodic signal because this is irrational number. This 1 by 2 pi is irrational number. So that's why you can say x of n is aperiodic signal. Correct? X of n is said to be aperiodic signal. Fine. It is said to be aperiodic signal. Very good. Now next question. Also this x of ये जो पीपी बनाने वाले हैं उन्होंने कॉमन मिस्टेक x ऑफ t की जगह x ऑफ n लिखना था और x ऑफ t लिख दिया सब जगह पे. चलिए, नो इश्यू. नाउ सी, नाउ so here conclusion is what? Each and every discrete time sinusoidal signal is not always periodic. It may or may not be periodic, as we can see here. So first conclusion number 1 is all the continuous time sinusoidal signal is always periodic, but all the discrete time sinusoidal signals are may or may not be periodic. It will be periodic under the certain condition. Now combination of continuous time sinusoidal signals are may or may not be periodic. Combination of continuous time sinusoidal signals are may or may not be periodic, but combination of discrete time periodic sinusoidal signals are always periodic. Always periodic. See, x of n is a combination of more than one periodic signal. x1 of n plus x2 of n plus x3 of n and so on. If it is a combination of more than one periodic signal, then the combination x of n will be always periodic. Why? It is always periodic. Why? See, this is periodic with the fundamental time period capital N. It is also periodic with the fundamental time period capital N2. It is also periodic with the fundamental time period N3. Okay, individual all are periodic. So here if you find the ratios like N2 by N1 and N3 by N1, it will be always rational number. Why? Because see, N1, N2, N3, N4 all are what? All are integer value. N1, N2, N3, N4 all are the integer values, and ratio of integer values always, ratio of two integer number is always rational number. So need not require to check whether the ratio is rational or irrational. Always rational number. Always rational number. Combination is always periodic. So we can say the combination is always periodic. Combination is always periodic, and the fundamental time period always period, always rational number. Always periodic, correct? And the fundamental time period fundamental time period is given by fundamental time period capital N given by LCM of N1, N2, N3, okay, LCM of N1, N2 and N3. So finally again conclusion, all the continuous time sinusoidal signals are always periodic. All the discrete time sinusoidal signals are may or may not be periodic. it will be periodic under certain condition. Condition is if omega by 2 pi is equal to k by n, k by capital N is a rational number, then it is a periodic with the fundamental time period capital N. Now, combination of continuous time sinusoidal signal may or may not be periodic, but combination of discrete time sinusoidal signal always periodic. So this is very much important conclusion. Now let us solve on this. Find the fundamental time period of the signal. So if individual periodic, then definitely combination will be periodic. So let us check individual is periodic or not. Omega 1 is equal to pi by 3 and omega 1 divided by 2 pi is equal to pi by 3 1 upon pi equal to 1 by 6. Of course, this is a rational number. This is the rational number. So this is periodic and periodic with the fundamental time period 6. Now here this omega 2 equal to pi by 4, omega 2 divided by pi. So divided by 2 pi, it is 1 by 8. Again, it is also rational number. So this is also individually periodic. So both are individual periodic, then definitely combination will always be periodic. So N2 is equal to 8. Now find the ratio. Now find the fundamental time period. So fundamental time period capital is LCM of 6 and 8. What is the fundamental time period? What is the LCM of 6 and 8? It is 24. You can cross verify also, guys. Find x of n plus 24. If it is equal to x of n, then definitely it will be periodic, and here it will be periodic only, guys. So the fundamental time period n is equal to 24. Is this clear? Tell me in comment box. Clear or not? So in this way we can find the fundamental time period. Now next question. Here also x of okay, now try this question. Try this question. Tell me whether this is periodic or aperiodic. Periodic, then find the fundamental time period. Additional phase shift doesn't alter the periodicity of the periodic signal. Periodic. If it is periodic, then tell me the fundamental time period. Here, omega 1 is pi by 3. Omega 1 divided by pi is 1 by 6. Again, this is rational number and the fundamental time period is equal to 6. Omega 2 is equal to pi by 10. Omega 2 divided by pi equal to 1 by 10. Okay. So here the fundamental time period is 10. Okay, the fundamental time period is 10. Okay. So of course individual periodic, then combination also periodic. What is the fundamental time period? Fundamental time period is 30. Very good. This LCM of N1 and N2, but LCM of 6 and 10. So fundamental time period 1 by 30. Correct? Fundamental time period is 30. Now let us take next question. check whether this is periodic or aperiodic. Aperiodic. If any one signal, any one out of two, any one signal is aperiodic, then the combination will be always aperiodic. Here, omega 1 is equal to 7 pi. Omega 1 divided by pi equal to 7 by 2. It's a rational number. Okay, and first signal is periodic. Divided by 2 pi 4 only. Here guys, this one omega 2 is 6. Omega 2 by 2 pi equal to 6 by 2 pi equal to 3 by pi, and this is irrational number. As this is the irrational number, so this is aperiodic. If any one signal is aperiodic, then combination definitely it is aperiodic guys. So here this combination is always aperiodic signal. Combination will always be aperiodic signal. Fine. Okay, next question. Now this is very much important question, and we can expect this type of question in GATE exam. See, read the question first carefully. Find the fundamental time period of the signal x of t equal to 7 cos 150 pi t plus 5 degree. Now it is converted into discrete time signal by the sampling process with the sampling frequency of fs equal to 200 Hz. Find the fundamental time period of the discrete time signal x of n. One continuous time sinusoidal signal is given. Now it is converted into the discrete time sinusoidal signal with the given sampling frequency. And if the converted signal is, that is discrete time signal, is periodic, then you have to find the fundamental time period of that converted signal x of n. How to start? So first of all, x of t is equal to 7 cos 150 pi plus 5 degree. Here fundamental frequency omega is equal to 150 pi, continuous time. Omega is nothing but 2 pi by capital T. Pi by capital T is equal to 150 pi. Omega equal to pi by capital T. So T is equal to 1 upon 75, correct? By 75 seconds. So this is the fundamental time period of x of t. 1 by 75 is the fundamental time period of x of t, and if you want to calculate the frequency of x of t, it is 75 Hz. Now it is converted into the discrete time signal by the process called sampling with the sampling frequency fs 200 Hz. So replace here t with n into ts. If you replace t by n into ts, then it will convert into discrete time. So x of t become x of n 7 cos 150 pi. Now t become nts plus 5 degree. Okay. So x of n is equal to 7 cos 150 pi n ts. What is the ts guys? Ts is nothing but 1 upon fs, correct? 1 upon fs, and fs is 200 plus 5 degree. So x of n is equal to 7 cos is 6, and this is 8. You can say this is t and 4. T pi by 4 n plus 5 degree, correct? Now this is converted into what? Discrete time signal. Now from here omega is equal to pi by 4, omega by 2 pi. Omega by 2 pi is equal to pi by 4 1 by 5 equal to 3 by 8. So 3 by 8 is a rational number. 3 by 8 number. So as 3 by 8 is the rational number, it is periodic. discrete time signal, converted discrete time signal is periodic signal, and the fundamental time period capital N is equal to fundamental time period capital N is equal to this very good question. Fine. This fundamental time period capital N is equal to 8 for the discrete time signal. Any doubt in this here to each and everyone? I hope all the students are getting this is very good question. Now question number 29. Find the fundamental time period of x of n equal to j power n by 2. This is also very good question. What is the fundamental time period? So instead of j, can you write like this? Power j pi by 2 cos pi by 2 k sin pi by 2. Cos pi by 2 0, sin pi by 2 1. It is so you can replace j with this j by e power k pi by 2. Now x of n signal equal to e to the power k pi by 2 power n by 2 e to the power j pi n by 4. Compare with e power j omega n. From here omega is equal to pi by 4 omega by 2 pi omega upon 2 pi is equal to 1 by 8 is a rational number. This periodic and the fundamental time period. Okay, fundamental time period is fine. Very good. I hope all of you are getting. Answer is 8. Next question. Now this is also a very good question, guys. Find the fundamental time period of signal x of n. Summation n is equal to minus infinite to plus infinite del n minus 3k minus n minus 1 minus 3k. What is the fundamental time period? So you can draw it graphically, guys. Put the different values of k and draw it graphically. You will get the fundamental time period. Now k equal to minus 1. If you put k equal to minus 1, then del n plus 3. It will be impulse at n equal to minus 3 with plus 1. Is at minus 3. If you put k equal to minus 1, it will 1. And here, if you put k equal to minus 1, and this del the minus 1 del n minus 1 plus 3 will be del n plus 2. Okay, so this is the impulse present at n equal to minus 2, n equal to minus 2, amplitude minus 1, amplitude minus, correct? Get minus 2 with amplitude minus 1. Now put del equal, put k equal to 0, guys. If you put k equal to 0, it will be del n minus del n minus 1. So one sample at origin with amplitude plus 1, one more at 1 with amplitude minus 1. Here at origin, at 1, the amplitude by minus, fine. Now here put n equal to 1 guys. If you put n equal to 1, then here del n minus 3 minus del n minus 4, n minus 4. This is at n equal to 3 and this is at n equal to 4. Amplitude is plus 1 minus 1 at 3, yes, and so on guys. Now see, this is minus 2 0 and here between minus 2 and 0, minus 1 of course is 0, sample value 0. Similarly 1 and 3, so here between 1 and 3 at 2 0. So similarly at 5 also 0 you will get, correct. If you put n equal to 2, suppose n equal to 2, n equal, yes, and here k guys, not n, should be k, the value k equal to 2, so it will be 6, here 7, at 6, 1, 7, minus 1. Now tell me the fundamental time period. At 6, at 7, 1, minus 1. Now check the fundamental time period and so on here, left hand side, right hand side also. Okay, so fundamental time period, these 3 samples first, the next these 3 samples, next these 3 samples, these 3 samples are making one pattern and repeat. Okay, so that's why we can say the fundamental time period is 3, capital N equal to 3. Fundamental, this is periodic signal and the fundamental time period capital N is equal to 3. Fundamental time period capital N is equal to 3. Is this clear? Fine. The fundamental time period capital N is equal to 3 guys. This is periodic signal and this is your fundamental. Okay. Next question. Now this is also very good question guys. 7 cos pi n square by 2. See, instead of n here it is n square. Now to solve this question, n square is there. So you can put the different values of n. You can put the different values of n and then you can check whether this is periodic or aperiodic. Put the different values of n and write in the sequence format and then check whether this is periodic or aperiodic. And cos is an even function. So whatever you will get for the positive value of n, the same amplitude you will get for the negative value of n also. Tell me whether this is periodic or aperiodic. Here, again, this x of n. So put the value of n equal to 0 guys. At n equal to 0, cos 0, 1. Correct? Cos 0, 1. That means here it is 7. Is 7. Now next, n equal to 1. So if you put n equal to 1, what about cos pi by 3? So it is 1 by 2 guys. N equal to 1 means 1 by 2. So 7 by 2. So it will be 7 by 2 for n equal to 0. 7 by 2. And I told you guys, as this is the even function, here also 7 by 2. Here also 7 by 2. Next, if you put n equal to 2 guys, n equal to 2, then cos 4 pi by 3. What about cos 4 pi by 3? Cos n equal to 2 guys, if you put n equal to cos 4 pi by 3, it will be what? Minus 7 by 2. Cos 4 pi by 3, that is pi plus pi by 3. Pi plus pi by 3, that is minus 7 by 2. Okay. Here also minus 7 by 2. If you put n equal to 3, so 3 pi cos 3 pi is nothing but minus 7. Yes or no? So here also you will get minus 7. One signal, that's why right hand side, left hand side both same. Next, put n equal to 4. If you put n equal to 4, guys, so it is 16. See, 16 pi by 3 equal to 16 pi by 3 is 5 pi 12 4. So 16 pi by 3. Calculate the value of 16 cos 16 pi by 3. I think it will be 7 by 2 only, guys. It will be 7 by 2 only, I think. Cos 16 pi by 3, guys. Five pi minus 5 by 3. 0 pi 2 pi 3 0 pi 5 pi 4 pi 5 pi or s minus 7 by 2 s. Again you will get minus 7 by 2, I think. Check once. All of you please check once. Minus 1 by 2, yes, cos yes, minus 1 by 2, correct, as I told you, minus 7 by 2. Minus 7 by 2. Next, here also minus 7 by 2. Okay. Next, now you can check periodicity and so on, guys. Also. Okay. Now tell me the fundamental time period. Tell me the fundamental time period. You have put n equal to 5, guys. If n equal to 5, then 7 by 2 will get again. You will get this 7 by 2. 7 by 2 here also 7 by 2. On. Now tell me the fundamental time period. What is the fundamental time period? Here also 7 by 2 will get. What is the fundamental time period? What will be the fundamental time period? Put n equal to 5, then it is 25. 5 by 3. Again 7 by 2. N equal to 6, then 7. Yes, correct only. N equal to 0, n equal to 1, n equal to 7 by 2, n equal to 2, minus 7 by 2, n equal to 3, that is 3 pi, equal to 3 pi minus 7, minus 7 by 2, then 7 by 2, periodic or aperiodic, 7 by 2, minus 7 by 2, next here, this is n equal to 1, 3, 4, 5, if you put 6, then 12 pi, 0, pi, pi, it is 7 only, guys. Next is 7. On. Now check once, all of you. This is periodic, aperiodic. So it is periodic with the fundamental time period 1, 2, 3, 4, 5 and 6. Fundamental time period is 6, guys. You can see here. The fundamental time period is 6 here, this one. 7. Then next again 7. So 7, 7 by 2, minus 7 by 2, minus 7, minus 7 by 2, 7 by 2. Then next is 7. And repeating. So that's why here the fundamental time period n is equal to 6. So in this way we can calculate whether the given signal is periodic or aperiodic. So this is periodic signal, correct? This is periodic with the fundamental time period x of n is periodic signal. Periodic signal with the fundamental time period. n equal to 6. N is equal to 6. This is clear? This is very much important. Next. Now see, this is important conclusion, guys. Important observation. See, x of t equal to sin bt. It is a periodic signal, correct? X of t is equal to sin bt, which is a periodic signal. But if you multiply this sinusoidal function with exponential decreasing function, then it will be aperiodic, guys. It will be aperiodic like this. See, this is the sinusoidal function. This is periodic. Okay, of course this is periodic. And we are multiplying it with the exponential decreasing function. If you multiply this sinusoidal with exponential decreasing function, then each and every peak value multiplied with exponential function, this multiplied by this, so this multiplied by this one, guys, correct? This one, this multiplied by this. So it is again sinusoidal only, but peak values are exponentially decreasing, guys. So as peak values are exponentially decreasing, you can see, suppose this is the first cycle, so this is the first cycle, same equal to second cycle. Amplitude also, not only duration, the amplitude also it should be same. Both the cycles should be same amplitude wise also. So here amplitude wise both the cycles are same, but here see, this is the first cycle, this is the second cycle. Duration is same, of course. Duration of this is equal to duration of this, but not only duration, here amplitude is different. Amplitude of this cycle and amplitude of this cycle both are different. That's why this is aperiodic. Okay, this is aperiodic, guys. Is this clear? Clear to each and every one? Very good. Now next classification, guys, bounded and unbounded signal. Next classification. What is a bounded signal? A signal which is having finite amplitude at any instant of time is known as bounded signal, otherwise unbounded signal. A signal which is having finite amplitude at any instant of time is known as the bounded signal. That is, the magnitude of x of t should be less than or equal to m, where m is any finite value. Okay. Bounded signal example, u of t. In u of t you can see at t equal to infinite also amplitude finite. We can say at any instant of time you will get the finite amplitude. That's a bounded signal. Exponential decreasing function. Here also, as you can see here, at any instant of time you are getting the finite amplitude. That's why this is also bounded signal. And example of unbounded signal like ramp function, increasing function, guys, gradual increasing, linear increasing. At t equal to infinite you are getting amplitude infinite. That's an unbounded signal, like exponential increasing right side or exponential increasing left side. So this is what unbounded signal. Fine. This is the unbounded signal. Here. So if you are getting infinite amplitude at any instant of time, then it is unbounded signal. And if you are getting finite amplitude at any instant of time, then it is known as what? Bounded signal. The next classification. Now one more classification is there, random signal and deterministic signal. So what do you mean by deterministic signal? A signal whose future value is expected or evaluated. A signal whose future value is evaluated at the present time. At the present time, that is known as what? Deterministic signal. And such signal will have a predefined or well-defined mathematical expression. Okay, so here it is written, a signal whose future value can be evaluated exactly at the present time, then it is known as deterministic signal. Such signal will have well-defined mathematical expression. On the opposite side, the random signal do not have any type of well-defined mathematical expression. Okay, example of deterministic signal is x of t equal to a sin omega t. So in this equation, this is the well-defined mathematical expression of sinusoidal function. So simply you can put the value of t, any value you can put. Okay, if you want to calculate the amplitude of this sinusoidal signal for 11 am of tomorrow, then also you can calculate. Fine. On the other side, random signal do not have well-defined mathematical expression like this, temperature of whole day. Okay. So this is what? Random signal. in which amplitudes are varying randomly with respect to time. So this is also one more classification, random and deterministic signal. The last classification is analog signal and digital signal. Okay, so it is based on the nature of amplitude. If continuous amplitude, then analog signal, and if discrete amplitude, then the digital signal. So continuous amplitude have analog signal have continuous amplitude like exponential decreasing like this. So this is what, this signal have continuous amplitude between 1 and 0, that's why it is analog signal. And here discrete amplitude means digital signal. So here amplitude between either 2 or 4 or -2 or -4, that's why if discrete amplitude, the digital signal, and analog continuous amplitude means analog signal. Okay, so this is all about the classification of signals, and from tomorrow I will start classification of systems, which is the last topic of this chapter. Okay, so all of you, thank you so much watching me live on Get Wallah English channel, and please provide your valuable feedback after completion of this session. Next part we will continue in subsequent module. Thank you guys, thank you.